Hello everybody, it is Mr. Strager, and today we are going to be talking about Big Ideas, Algebra 1, Section 1.4. Now, 1.4 is a doozy of a section. What I mean is, it is very long and covers a lot of ground. So, feel free to pause this video at any time if you need more clarification. Feel free to skip around if you need to, because this is going to be a bit of a longer one. Section 1.4 is all about absolute value equations. Now, many of us have heard of absolute value but haven't used it in quite some time. So I really briefly want to review what the absolute value is, as it is crucial to understanding the rest of the lesson. So, let's say you're looking at some weird symbols that look like this. Almost like parentheses, but not curved. These are absolute value symbols. And they act like parentheses in the sense that everything that's inside of them is contained. The absolute value is defined as a number's distance from 0. So if I make a quick and dirty number line here, it's not going to be perfect, but it'll do. There we go. And if I'm looking at the absolute value of -3, what it's asking us is, hey, how far is -3 from 0? We can look at this and we can say, well, it's 1, 2, 3 away from 0. The absolute value of -3 is 3. It's pretty self-explanatory. However, there is another number on this number line that is 3 away from 0. Can you spot it? If you said +3, you are absolutely right, because it's 1, 2, 3 away. This means that we can write the following statement. The absolute value of 3 equals 3 as well. What this means is, the absolute value, you can think of it as basically just turning whatever's inside of it positive. If it's negative, it becomes positive. If it's already positive, it stays positive. You'll also see that for every absolute value, its negative counterpart will have the same value. So for instance, the absolute value of -1 equals the absolute value of 1. Both are 1 away from 0. We can extend this principle one step further. What if I had something like this? The absolute value of x equals the absolute value of -x. This means that no matter what x is, I could put in any number, and this statement is true. If I put in 2 here, then this would be -2. Well, 2 is 2 away from 0. -2 is also 2 away from 0. So it works for all numbers. Now, it wouldn't be in high school math if this is where we ended. Because in algebra, you know we're going to use equations somewhere down the line. Let me give you a quick example of one. This is going to be a very, very basic equation. If I asked you to solve for x here, what values of x are 12 away from 0? Well, you can make a number line that's 12 units long, but I think many of us might have picked up on the pattern. One of the x's is going to be 12. 12 is 12 away from 0. But the catch is, you won't just have one solution for x. You will have 2. Most of the time, when you have an absolute value expression or equation, you will have 2 solutions. They won't always be both one positive, one negative. You might have both be positive, both be negative, but no matter what, you'll have 2 solutions. Now, before we get any further, I do want to fill in the definition for an absolute value equation. It's just an equation with an absolute value symbol in it. We're going to skip this definition for now, but we will come back to it later. I assure you, we will definitely come back to it later. Alright, before we do any crazy equations, I want to talk about some of these properties real quick. These can be a little bit tricky to read, but it's important to get started with reading them because Algebra 2 and pre-calculus looks like this. I know, it can be a little intimidating, but we will get very good at reading these over the next couple of classes. It says, let A and B be real numbers. That means anytime you see the letter A or B, you can replace them with any number you want, as long as it is a real number. The first property says, the absolute value of some number is greater than or equal to 0. So if I gave the absolute value of negative 500, it must be greater than or equal to 0. And this works because the absolute value of 500 is positive 500. Remember, all the absolute value does is it makes whatever's inside of it positive. We're all good. That works. Number 2, we've already talked about. Any absolute value and its negative version share the same result. The absolute value of negative 3 and the absolute value of 3 are both 3. Number 3 is interesting, because now we're using two variables. It says the absolute value of any two real numbers is the same as the absolute value of one of those numbers times the absolute value of another one of those numbers. So let's put in some numbers for this one, because this one is a little crazy. Anytime you want to test out some numbers for variables, I recommend trying a positive and trying a negative. Just so happens that there's two variables here, so we can do both in the same example. I'm going to say that A is equal to 3, and B is equal to negative 2. I put the parentheses to separate it from the multiplication sign. What is the absolute value of 3 times negative 2? Of course, we're looking at this side of the equation first. Well, 3 times negative 2 is negative 6, so it's the absolute value of negative 6. And the absolute value of negative 6, well, if we just think about how far away is negative 6 from 0, it's 6 units away from 0. The second half of the equation on this side says that 6 will also be equal to the absolute value of A times the absolute value of B. So let's use the same numbers and see if that's correct. Our A value is 3. Our B value is negative 2. Well, we know the absolute value of 3. 3 is 3 away from 0. So it's 3. Negative 2 is 2 away from 0. So it's negative 2. Or sorry, I apologize. It's not negative 2, it's positive 2, because it's 2 away from 0. 3 times positive 2 is also 6. This last rule works the same way. So if you want to skip over this next part, you can. But for those who want to see how it's done, this is saying that the absolute value of some number divided by some other number, or it can be the same number, equals the absolute value of the top divided by the absolute value of the bottom. So if I chose the numbers 10 and negative 5, the absolute value of 10 divided by negative 5 can be simplified as, well, 10 divided by negative 5 is negative 2. So it's the absolute value of negative 2. And we know from the previous problem that the absolute value of negative 2 is 2. On the other hand, we have this. Taking the absolute value of the top divided by the absolute value of the bottom. And I'm writing this in a weird way, and you'll see why in a second. Here we go. The absolute value of 10, well, that's 10. The absolute value of negative 5, well, that's 5 away from 0, so it's going to be 5. 10 divided by 5 will equal this same 2. So they're equal. The only catch is b can't be 0, because anytime you divide by 0, right now we don't have the tools necessary to calculate that, because it's basically infinite. We don't go too deep into that in this class, just know that dividing by 0 is very problematic. Alright, now we're going to start talking about absolute value equations. So, as I mentioned before, an absolute value equation is just an equation that has an absolute value in it. So let me give you an example. The absolute value of x plus 3 equals 5. And our goal is to figure out a method for solving this. Now, when you're looking at this for the first time, it might be nice to try to guess, or try to guess and check, I should say, what numbers of x work. Well, as I'm looking at this, the absolute value of something plus 3 equals 5. I happen to know that 2 plus 3 equals 5, so what happens if I put a 2 in here? Well, I'd have the absolute value of 2 plus 3 equals 5, which is the same as saying 2 plus 3 is 5, so the absolute value of 5 is 5. And, oh, would you look at that? The absolute value of 5 is positive 5. So we know that this one works, which means one of our solutions is x equals 2. Perfect. Many of us might stop here if we were using a forward-thinking method. But remember what I said. There are always two solutions. As you think about it more and more, you start to realize you don't just need to figure out an expression that equals 5. Because the absolute value turns everything positive, we need to find an equation that, once we simplify it, will give us negative 5 in our absolute value brackets. Because then the absolute value of negative 5 is 5. So what plus 3 is negative 5? If you said negative 8, you have found the other solution. Negative 8 plus 3 is negative 5, and the absolute value of negative 5 is 5. So these are both of our solutions. You must list both solutions to be correct if the answer has two solutions. This is good and all, but it'd be nicer if we had a method that works every time to figure out what those two numbers for x will be. And I'm about to tell you one. Real quickly, we talked about inverses. So the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. Right? Well, these are the inverse operations. But there are also processes that are inverses. In particular, the opposite of the absolute value is what I like to dub splitting. What I mean by that is, when you have an absolute value sign that you are trying to undo, you can split your original equation, like this one, into two versions of itself. One in which this side is positive, and one in which this side is negative. The reason why this works is because, remember how I said I needed 5 and negative 5 inside of here? Well, if we set our goal out here to be 5 or negative 5, then we can just solve like normal, right? So let me show you what I mean. Let's say my goal is for x plus 3 to equal 5, because if x plus 3 is 5, then this entire expression is positive 5, which is equal to that. We can just solve the equation x plus 3 equals 5 to figure out what that x value is. I'll solve it in a moment, but I want to show you the other part. Remember that other value for this entire expression that would give us 5? It's negative 5. So if x plus 3 equals negative 5, then we can also solve for x, because it'll equal 5 once the absolute value is taken. So we have this version, x plus 3 equals negative 5. I call these the positive and negative versions. Not because everything in one of them has to be positive and everything in the other needs to be negative. That is a very loud train. I apologize, everyone. But because what we want to do, what our goal is to get rid of everything to get our x alone on this side. It's the positive side because this is like the good outcome where you didn't have to change anything. This over here is our negative side because we had to flip a part of our equation. Astute viewers will know that to get rid of the positive 3, we subtract it on both sides. That's what gives us our x equals 2. It comes from the positive version. On the negative version, though, look at what else we have to do. We also have to subtract 3 from both sides, because that'll cancel out the plus 3. In a simple absolute value equation, your steps will be the exact same for both versions, both the positive and negative versions of our equations. We're going to try just one more practice before we move on to something a little bit trickier. I want us to take a look at number 3. Actually, I apologize, everyone. We're going to take a look at number 5. Because number 3 has some nasty numbers with it. Number 5 looks crazy. It's because it's a lot to do. But if we tackle it step by step, we will reach an answer for sure. So, the problem is 3 times the absolute value of 2x plus 5 plus 10 equals 37. And this is where something very important that I skipped over in the notes comes into play. In the notes, notice how we talk about an equation that looks like this, where it's just the absolute value on this side and just a number on the other side. Interesting, huh? In order for us to solve an absolute value equation, in order to get rid of this absolute value sign, we treat it like parentheses in reverse Pemdas. Remember reverse Pemdas? Well, it's the one that basically says the order in which we have to get rid of things. And I mentioned that we treat absolute value like it's parentheses. That's all the way at the top. That's the very last thing we have to get rid of. So what we need to do is we need to get rid of everything else by undoing them. So we have this 3 being multiplied, and we have this 10 being added. Which should we get rid of? If we look at reverse Pemdas, we see addition and subtraction is the very bottom step, meaning that's the first thing we have to get rid of, is any addition or subtraction. Now you might say, can't we get rid of this plus 5? But remember, it's in parentheses for the purposes of this problem. We can't get rid of something when it's in parentheses. That's the last step. So we have to get rid of this plus 10 by subtracting it from both sides. Once we do that, we get a new equation, 3 times the absolute quantity, 2x plus 5, equals 27. Okay, we're getting there, we're getting there. Next step is we got to get rid of this 3. So how do we get rid of multiplying by 3? Well, we divide by 3. And here is a very important key for the absolute value. Sometimes distributing the 3 will work just fine, but other times it will not. Because those situations are so, well, situational, in general, we want to just undo the multiplication step. We don't want to have to worry about, is this one where I can distribute or is it not one where I can distribute? In general, it is safest just to get rid of the 3 on the outside, not by distributing it, but by dividing it out. It's just simpler that way. Not saying that you have to, but you better keep a good eye out for when it doesn't work, if that's the case. So we end up with this, because 27 divided by 3 is 9. Is there anything else that we need to simplify before we can get rid of the absolute value? There's no more addition or subtraction, multiplication or division, or exponents. So yes, we've reached the point where we can now get rid of the absolute value symbols. As a reminder, to get rid of the absolute value, we split into 2 equations. We see how this one equals 9? That means we want this inside 2x plus 5 to either equal 9 or negative 9. Because both of those, when you take the absolute value, will give us 9 again. So we can set up those 2 variations. 2x plus 5 equals 9 is one of the things we're trying to find, because we want 2x plus 5 to equal 9. Or 2x plus 5 equals negative 9. Because again, the absolute value of negative 9 is still 9. These are our 2 versions. So now we solve these like we solve any multi-step equation. We do reverse Pemdas again. I know, it's a long process. In this left equation, which I'm going to look at first, we have a plus 5. And that means we have to get rid of it first, because it's the bottom step. So we subtract 5 from both sides, giving us 2x equals 9 minus 5 is 4. From here, there's only one step left to go. We have to get rid of the 2 in front of the x. Well, that 2 is being multiplied, so we divide both sides. 2 divided by 2 cancels out to just give us 1x. So we write x equals 4 divided by 2 is 2. Sure enough. And like I said, in a simple absolute value equation, where this is pretty much all you have, just a number on the other side and your absolute value over here, the steps will be the same. So we can just copy down the steps. Keep in mind, though, that your numbers will end up different. Here, 9 minus 5 was 4. On this version, negative 9 minus 5 is negative 14. That's how we get 2 different answers. From here, of course, we have a 2 in front of our x, so we divide by 2, and we get x equals negative 7. And these are the 2 solutions. If you are ever asked to graph your solutions, like in this problem, all it means is put a dot where your 2 solutions are. So I put a dot at negative 7 and put a dot at 2. That's the graph of our solutions. We'll be talking much, much more in depth about graphing these solutions in Unit 2. However, it's good to get the practice in now. All right. Before we move on, there are a couple of very special equations we need to talk about. Remember how I said 99% of the time you will end up with 2 solutions, like in this problem here? Well, we're going to talk about that other 1% because we need to be able to identify what that 1% is. Let me ask you sort of a trick question. With an equation like the absolute value of x equals negative 6, what values for x will make this solution true? Pause the video and think about it for a couple of seconds. Have you thought about it? Well, the more you think about this question, the first answers that come to mind are like 6 or negative 6. Here's the problem with both of these. The absolute value of 6 and the absolute value of negative 6 are the same because of one of our properties that we talked about before, property B. But both of these absolute values will just give us positive 6. They're both 6 away from 0. So, in reality, there's no number I could put for x, no real number, that will give us a solution. When this happens, if you ever end up with a negative number on the other side of your equal sign, you don't even need to do the problem any further. You don't need to split the problem. You can just say no solutions. Now, does this mean that anytime there's a negative number, you can just say, oh, no solutions, I'm done? Well, that's not correct either. What if I gave you a problem like this? The absolute value of x. Let's go with minus 10 equals negative 2. You might go up and say, oh, there's a negative, I'm done, there's no solutions. But we have to simplify before we can conclude anything. To simplify, we would add 10 to both sides, because that's what'll get rid of the negative 10. Negative 2 plus 10 is positive 8. That's a two-solution answer. X equals 8, x equals negative 8. So be careful and make sure you simplify before you decide for sure how many solutions there are. Alright, let's try just one more problem together. This is going to be the other type of solution you might see. Let's say I had the problem x plus 1 plus 1 on the outside of the absolute value symbol equals 1. I just like to use the number 1 for this one. Get it? For this one? Here, on this problem, we would first want to simplify before we can conclude anything. So we subtract by 1. Alright. So we subtract 1 from both sides, and we end up with x plus 1 in absolute value symbols equals 0. Okay, cool. So we have to do our split as always. We have what I dub the positive version and what I dub the negative version. Alright. So we got to think to ourselves, well, with the positive version, we can just keep everything the same. We want to find a value for x where just x plus 1 equals 0. So we get x plus 1 equals 0. But when we're thinking about the negative version, things get a little weird, because this is where we would normally try to find a value of x plus 1 that equals the negative version of the other side. There's no such thing as negative 0, though. Negative 0 equals 0. So our two equations will look the exact same. Not only will they look the exact same, when we solve them by subtracting 1 from both sides of, well, both equations, you would normally do this one at a time, like the left side then the right side, you'd get x equals negative 1 and x equals negative 1. Here's the rule for why this works. If you simplify and have a 0 on the other side of your equation, you will only have one solution. That solution could be 0, it could be negative 1, it could be 25, it could be anything, but they're the same. That's the reason why it's one solution, because there's only one answer for x. Alright, we have talked about quite a bit here, but we are not quite done. There is one more thing we need to talk about. On the bottom of page 20, not the very bottom, but close to the bottom, you see solving equations with two absolute values. You might be thinking to yourself, oh boy, time for this to get even more complicated. Well, I do have some relatively good news for you. It's not actually as complicated as it seems. Let me give you an example of two equations that we could solve. Now, fair warning, we are probably going to get a fraction for one of these, but that's just because I'm freehanding these equations. Here we go. 2x plus 5, or sorry, the absolute value of 2x plus 5 equals the absolute value of x minus 1. And this looks crazy. How do we even know how many solutions we have? Well, we can actually figure out how many solutions we have by, instead of looking at these, looking at something a little more simple. Let's pretend, instead of all these complicated numbers, we just had the absolute value of x equals the absolute value of some number y. Now, I don't know if these numbers are the same yet or not. We'll eventually show that they have to be the same, but I don't know. I'm just using two different variables for right now. Well, if these two absolute values are equal, and I split my x, that means that I would have an equation that looks something like this. I would have x equals positive y, and x equals negative y. Okay, not that crazy. What if, instead of trying to have my positive and negative versions of y, I try getting my positive and negative versions of x? Well, I'd end up with the equations where y is positive, x is positive, so I get x equals y, and then I'd end up with negative x equals y. Notice that in all of these situations, we either have x and y are the exact same, or x and y are opposites. For instance, if I plugged in the number 3, in this one, x would be 3, y would be negative 3. Well, this statement isn't quite true. But when we have the absolute value signs added back in, then we see that it can be. Let's pretend for a second that x and y are both 3. Then, the absolute value of 3 equals 3, because what do both of those absolute values equal? Well, equals 3. So, that's all good. What if, like in one of the examples, we had a negative x? So, x is negative 3, y is positive. Well, the absolute value of negative 3 is 3. The absolute value of 3 is 3. So they're the same. What if I switched it around? What if x was positive 3 and y was negative 3? It would still work, because this is still equal to 3, this is still equal to 3. And then, of course, for one last example, what if x is negative 3 and y is negative 3? Well, again, the absolute value of negative 3 is 3, so they're equal. What we end up with, even though it's 4 possibilities for equations, we really have 2 situations. Either our x and y are the exact same, or x and y are opposites. What this means for our equation is this. We can split it into 2 versions. One where x and y are the exact same. This would be x, this would be y. So it would just look the exact same. If 2x plus 5 and x minus 1 were the same, then we can write 2x plus 5 equals x minus 1. Okay, well that's nice and all, but what about these ones, where one of them is negative and the other one is positive? Well, that's the fun part. Let's make one of these expressions negative and one positive. You can choose which one you want to do, but to keep it looking like the ones we've already done, I'm going to make this x minus 1 part negative. We would have the equation 2x plus 5 equals, now remember I said you have to make the entire right side negative? This is where that comes into play. Negative x minus 1. Before I start solving with different steps, I want to see if I can simplify this one. Well, I have a negative. I have parentheses, not absolute value symbols. So if I have parentheses, I can distribute the negative. Again, this negative is like negative 1. So what's negative 1 times x? Well, it's negative x. What's negative 1 times negative 1? Well, it's positive 1. So my new equation is this. 2x plus 5 equals negative x plus 1. Now let's go ahead and solve it step by step. Very first step that I notice is both of these equations have a variable on both sides. So let's look at the left one first because it looks easier to me. And let's get our variables on one side. We learned this in 1.3. If I wanted to get all my variables on the left, I have to get rid of my variables on the right. How do I get rid of x? Subtracting x. But whatever you do to one side, you have to do to the other. So we end up with x plus 5 equals negative 1. Then, of course, we also want to get rid of this plus 5 here. We want to get all of our constants on the other side. So to get rid of plus 5, we subtract 5. That'll give us x over here and negative 6 over here. All right, that's our first solution. Very nice. Now all we need to do is solve this mess. This is where the steps will vary, because notice how we can't subtract x anymore. Subtracting x will give us negative 2x. That won't help us. Once you have other variables involved on the other side, things get messy and that rule flies out the window. Because the opposite of negative x is to add x. Well, that'll give us 3x plus 5 over here equals 1. Okay, how do we finish this off? Well, we want to get our constant term, plus 5, over on the right side. So we subtract 5 from both sides, giving us 3x equals 1 minus 5 is negative 4. This one requires an extra step, you might notice, and that extra step is to get x by itself. So we will divide by 3, because that'll get rid of multiplying by 3, leaving us with x equals negative 4 thirds. We now have our two solutions. X equals negative 6, x equals negative 4 thirds. I do have one more thing that we're going to go back to, because I mentioned we were going to jump back to at the end. It's our last vocabulary word. Extraneous solutions. Now, this is going to be unfortunate for some people who thought we were just done with absolute value. That's because we are not quite done. Unfortunately, absolute values are not without their flaws. Sometimes you end up with an answer that looks like it makes sense, but really does not. Let's try. Well, let's first talk about the definition of an extraneous solution. I already have the notes out. An extraneous solution is an apparent, keyword apparent, solution that must be rejected. Why does it have to be rejected? because it doesn't satisfy the original equation. Because it does not satisfy, in other words, it doesn't solve the original equation. Now, at this point, I'm already hearing in my head, Mr. Strager, what? Yeah, trust me, I feel you on it. It's going to be a little weird. Let's say we have the following equation. 2x plus 12, all in absolute value symbols, equals 4x. And we solve this one like normal. Is there anything other than our absolute value over here? Well, no. What that means is there's no addition or subtraction, multiplication, division, exponents. We skip right to the parentheses step. And to get rid of the absolute value parentheses, we would split it. So far, so normal. On our positive version, our left version, we want to get an expression for 2x plus 12 that'll equal 4x. So we say that 2x plus 12 equals 4x. On our right version, remember that negative 4x in absolute value symbols will also equal 4x. So we want to get an expression where 2x plus 12 equals negative 4x. Okay. Let's get all of our variables to one side of our equation. On this one, I'm going to choose to subtract 2x from both sides. This will be the easiest way of doing it because, look, I end up with 12 on its own side, which is what we want, equals 2x. And, of course, the next step would just be to finish the problem. Well, we want to divide by 2 on both sides, because that's what's going to get rid of multiplying by 2. We get x equals 6. It doesn't look extraneous to me, it looks pretty normal. What about the other side? Well, we subtract 2x from both sides, because we want to get them all on this side. That gives us 12 equals negative 6x. Then, to get rid of the negative 6 in front of the x, we divide it out, and we get x equals negative 2. Mr. Strager, you said we'd end up with a weird solution. I did. But Mr. Strager, these are totally normal solutions. They are not. What happens if we plug in 6 for x in this problem? Well, let's do it off to the side here. It doesn't need to be very neat, we just need to plug it in. We'd end up with the absolute value of 2 times 6 plus 12 equals 4 times 6. Okay, well, 2 times 6 is 12, plus 12 is 24. It says the absolute value of 24 equals 4 times 6. And yeah, the absolute value of 24 equals 24. That's a green check mark. X equals 6 is a totally normal solution. Let's try it with negative 2. 2 times negative 2 plus 12 in absolute value equals 4 times negative 2. Okay. Well, let's simplify this. 2 times negative 2 is negative 4, plus 12 is going to be positive 8. 4 times negative 2 is negative 8. Uh-oh. I'm getting a flashback. What do we see that makes this solution problematic? It all goes back to our number of solutions. If you have a negative when everything but your absolute value is simplified, we have no solutions. There is no case in which the absolute value of 8 equals negative 8. So, what that means is, negative 2, we were able to solve for it and it looks like it's a solution. Negative 2 is actually not a solution of the absolute value equation. You must check for extraneous solutions anytime there's another variable on the other side of the equation. Anytime there's a constant, you're going to be fine. Those equations are simple enough that it won't have any weird solutions. But throw a variable in there, and you always need to double check. This equation only has one solution, and that solution is x equals 6. Because x equals -2 just doesn't work. Whew, that was a long set of notes, everybody, so please make sure you stretch, take a breather, get something to drink. I am looking forward to seeing you next class. Take care.